Welcome to week 5 of the Data Engineering Nano Degree program. I am Javier Ortiz. I am your mentor throughout this program, and I'm really happy to talk to you guys again. So before we begin, just a couple of reminders. Don't forget to participate in our Slack channel, DEND session 963. Each week on Tuesday, I post a weekly roundup and includes all the lessons that you need to go over during that week in order to be on schedule. Any scheduled events such as this webinar, the AMA that I hold on Mondays, and the link to schedule a one-on-one meeting with me. Also, any deliverables that we have due and any reminders. So this week's reminder is that it may take up to 48 hours to receive the email approving the AWS credit. So please wait the 48 hours. And if you still haven't received the email, please don't hesitate to get in touch with me. Awesome. So see you on Slack. And with that being said, let me share it with you today's presentation. All right, so today's webinar is titled Intro to Data Warehouses and Exercise Walkthroughs. So we'll go over an introduction of data warehouse, and then I'll walk you through the first set of exercise of lesson number 1 of data warehouses. So, and this is what we're covering today. So what are data warehouses? A data warehouse is a system that retrieves and consolidates data periodically from the source system. So you may have your relational database that you use for the operational processes day in, day out, but these RDBs might get a little bit complicated because they are suited for your operational processes. But sometimes you would like to query these databases, and these queries might get very complicated. So what you do is you consolidate this data from the RDB and you retrieve it into a system that is better suited for analytical activities. So these data warehouse will be updated in batches. So it's not as soon as an event happens, the data warehouse will be updated. That's what you have your RDB for. But you can update this periodically to keep your data, your historical data, fairly up to date. But what you want this data warehouse to, the purpose of it is to be better suited for analytical activities, not operational processes, but analytical activities. So the best model that suits, one of the best models that better models that suits these requisites is dimensional modeling. And dimensional modeling, as we saw in the previous unit, is basically denormalizing your tables and have a star schema that has a fact table in the center with some dimensional tables coming out of the center. And let me show it to you. So this is your regular RDB. As you can see, it's pretty complicated, and it can be really complicated to write analytical queries because you have to do a lot of joins. And this might be awesome for your day-to-day operations because you want to keep it updated and you really don't want any duplicates, and you have like a set amount of users that are going to use it. So this works fine for your day-to-day operations, but for analytical queries, you want something more simplified, something like this. So the things that we care about that we're going to query analytically, we just denormalize those tables into this star schema. And this process can be done with an ETL. As we saw in the last unit, ETL stands for extract, transform, and load. So basically what we're doing, we're extracting data from the source, we're transforming it in some way and loading it into these, which becomes now our data warehouse. So I'm going to show it to you in the workspace provided in the classroom. All right, so this is lesson 1. And first, it gives an introduction of data warehouses, and then we come to the ETL demo. So what we're doing, as I show you, just show you, we're going to extract the information from the relational database, transform it, and then load it into our star schema. So star's really simple. It provides some code in order to create a database and connect to that database, so you don't have to create it yourself. So this creates, basically, if you run this code, it creates these relational database. All right. And the first lines of code basically is for you to get familiar with the relational database. So you count all the lines that are part of the tables, you get the results, how many rows each table consists of. Then you can run this code to see the minimum date and the maximum payment date, so that you know what dates you are dealing with, where events in the database occur. So for example, we have the district and the number of events that take place in each district. Oh, actually, this one is a to-do. So let's go over it really quickly. I was just hovering over it really quick. Okay, so you need to write a query that displays the number of addresses by district in the address table. So what the teacher recommends is that you take this image, you right click on it, open image in a new tab, and in that way you can just show them side by side. All right, so that you have like quick access to this table. All right, so displays the number of addresses by district in the address table. So we have the address table over here. And basically what we want to know is the number of addresses, all right? So since this table is filled with just addresses, we want to count the number of rows in this table, but we want to group them by district so that we know how many rows each district refers to in this table. And we're going to limit the table to top 10 districts. So I'm just going to select the district because that's the column that I want to partition my data by. And then I'm going to count. And this count, basically the star counts all the rows, and just select the table from address. I'm going to group by the first element, order by N. When you do the desk, basically you order them from the highest value to the lowest value. I'm going to limit my result to 10. And when you print, you should have your result match this result. So the first part of the exercise is really straightforward. Let's move on. All right, so you have another demo, and then next part of the exercise. So this part over here, if you've if you connected to database recently, you don't need to run this, okay? So you can just keep it and run this code. Okay, so this, you continue to do some analytical stuff with the database. So it gets a little bit complicated, but it's just for you to understand the database a little bit better. So basically, we select different columns from film so that you understand the table, from payments so that you can see the table, inventory, the same. Now get the movie of every payment. You have this code already written for you, and it's basically getting the movie, the amount that was paid, the date, and the customer ID, and showing it to you. And you are retrieving this data from many tables, all right? From 4, I think. All right, and this is the first query that you have to write. So write a query that displays the amount of revenue from each title. Limit the results to the top 10 grossing titles. Your results should match the table below. So what I would like to get here is we want to get the amount of revenue from each title. So we know for sure we're going to group by title, okay? We want our data partitioned by title, and title is found here in film. So it makes sense to select our data from this film table, all right? And then we want the revenue. The revenue is defined by the amount which I have here in the payment table. So I know that I need a sum, because sum, that function is going to add all the amounts that match a certain title, right? So I have here the title, sum, the amount as revenue. And then here I select the film table. And don't forget, you can use these aliases. So film, now every time I refer to film, I can use the F, and you can apply this to any table. And basically, this is a map. How can I get from film all the way to payment? All right. And now the path that I decided to use here is going from film to inventory, from inventory to rental, and from rental to payment. You see, the cool thing about relational database is that all these tables are related. And when you match certain column here with a column over here, you can be sure that they're going to refer to the same row or same data point. All right. So I decided to join inventory. And what does inventory and film share? They share a film ID. So the title that I'm looking for, that I'm partitioning my data for, by the film ID that this title has, all right, I'm going to link it to this film ID in inventory. And from here, the inventory ID that this film ID has, I'm going to link it to this rental ID. And finally, the rental ID that this film ID has, that this title has, I'm going to link it to this rental ID. And in that way, I can be sure that all the amounts are going to match the rental ID, that are going to match this rental ID, are going to match this inventory ID, that are going to match the film ID, that are going to match the title. So that's the way it works. It can get a little bit complicated, but just try to find the path and find what element both tables share, all right? And you just have to join each table, and you have to join them on the element that both tables share, all right? Don't forget to group by the query by the column your partitioner data by. You can order by, here for example, I'm ordering it by revenue as requested over here, and I'm limiting my results to 10. And these two should match. All right, now let's move on. Here we're doing similar queries. These are already done for you. I suggest you just read them so that you can understand them. Get the city of each payment, and it follows a similar process as we did with a previous query. Now here we have a to-do. Top grossing cities, write a query that returns the total amount of revenue by city as measured by the amount variable in the payment table. All right, so we know that we want our data partition by city, all right? And we want to sum all the amounts that refers to a certain city. Okay, so we can start with city, and city has its own table. So from this table city, I can pick the city, which I do here. And from payment, I can get the amount and sum all the amounts, and it will partition all the amounts by the city. Now the thing is, how do I get from city all the way to payment? And the path that I decided to use was go to address first, and then from address, go to customer. And from customer, I can get to payment. So it's not that long, all right? And first, what does city and address have in common? All right, I see that they have a city ID and a city ID. So that's how I join city and address. Now, what does that address and customer have in common? Address ID and address ID. And finally, what does customer and payment have in common? A customer ID and a customer ID. So I join each of those tables on the elements that they share. And finally, I just need to group by my first element, which was indicated over here. All right? And order by revenue, desk so that it's from the highest to the lowest, and limit my result to 10. Okay. And that is query number 2 that you have to do. And we have a final, well, this is already done for you. Shows the total revenue by month, follows a similar pattern, but it has like this fancy function, extract, which takes the month from this date, and we're going to use it for our next query. You have this over here that also uses extract and shows like a big table. And we've arrived to our sum of revenue of each movie by customer, city, and by month. So we're going to return the total amount of revenue. So we know that we're going to need a sum. We're going to sum the amounts because that is how revenue is measured. And we need to group by city and by month. All right. So, for each movie. So we're going to group by movie first, then by city, and then by month. And the way we do that, we first write the alias of the table that we're taking the title, and title is taken from film. Film has the alias of F, so that's F.title. Then city, I get it from the city table. City has an alias of C and I. You can decide your own aliases, by the way. So if you want to write city as C, just the C, or like CY or whatever, I suggest you use something that is shorter, because that's the point of the alias, to have something shorter and something that makes sense. All right. So city, and then I'm going to extract month from this payment date. As you can see, this is a data type. And the extract function works for data types. So this is going to extract the month as a number from this data type. And I have selected an alias of month. And here's my sum that I named revenue. And that's as simple as that. And what I want to do now, since I'm selecting, where I'm starting is the film table, I need to get all the way to payment, but in the way I need to get to city, and that's it. All right. So my first stop is going to be in inventory. And inventory and film, they share film ID, so I'm going to join them in film ID. And from inventory, I'm going to rental. And rental and inventory, they have inventory ID in common. So I'm going to join them on that. And then from rental, I'm going to payment, and I've arrived to my first destination, and I'm going to join them on rental ID. Once I'm here, I'm going to join customer, because that's my next stop to get to city. And I'm going to join these two on customer ID. And finally, two more steps. I'm going to join customer to address. I'm joining them in address ID and address ID over here. And finally to city, and I'm joining address and city by the city ID over here. So I've arrived to my last destination. So I'm sure that where I started was the title. The title and everything that is associated with this title matches all these tables, right? All the way to city. And don't forget to group by all the elements that are not part of this sort of functions. Every time you use count, every time you use sum, don't forget that everything that is left out of those aggregations needs to be in the group by, all right? So that's kind of like the rule. And then order by, in this case, it makes sense to order by month so that I have my highest revenue title for each month. All right, so I'm going to order them by month and from revenue. And what I get is all the titles, the city where they rented, and the month. And for each month is going to order them by the highest revenue, right? And we can see that these match this table. All right. So this is the first 3 steps of the ETL. So we haven't done any ETL yet. what we've done just now is just basically understanding how to navigate these tables, how to join the different tables. And it takes practice. What I suggest you do is try to pause the video and work along with the video, or try to solve it just by yourself. And whenever you get stuck, then you open the video. But the best way of navigating this is by practicing it. So let's go with step number 4. And step number 4 is where we're changing this RDB into a simpler star schema, which is better suited for our data warehouse. Now I'm connecting to the database, and this is the database that I would like to use now. So let me open it in a new tab, and I have it over here. And what we're going to do first, we're going to create the tables, all right? So what the ETL is going to do is going to extract, transform this data, and load it into this table. So we need to create these tables first in order to have a place to store the data, to load the data. So create the DEND table. So we're going to start by creating this table. And it's really, really simple. What we're going to do, we're going to use this statement so that our query works. And it's the same statement that you use for Postgres. Is create table, then the name of the table, the date. And basically you go field by field. So we start with the date key. And this, it can be an int. Because you have all over here the date, the data types, I'm sorry. And it's going to be not null, it's going to be my primary key, all right? And you can see that the tables really clear on what they want the primary key to be. And then I just name date, then the year, then the quarter, month, day, week, and it's weekend. And just making sure that I follow the requirements for data types. Date, I want to be a date. So I have it over here. This can be a small int, small int, small int, small int, small int, and this is a Boolean. So I just write it like this, and boom, done. I have my table created. All right, and here this code is just to check that you created the table with the correct data types. So these should match this table. Awesome. I think these other 3 tables, the DEM movie, DEM store, and DEM customer, are created for you. And as you can see, just they follow a serial primary key. Basically, what this does is that like it creates a primary key that augments as a series. So it's nothing too fancy. I think you use the serial primary key for your previous projects. And that's pretty much it. You shouldn't get an error. I got this error because I've run this so many times and I didn't drop the tables. But since this is your first time creating the tables, you shouldn't get any errors. Now create a fact sales table. Now here, there's something that you didn't see on the lessons, and is the references constraint. And basically what this references constraint does is, since you want your fact table to come out of your dimensions tables, basically this constraint prevents you from using a field that hasn't been used before. All right. So for example, if you have, if you want to include a movie key, but you haven't included a movie key from this dimension, there is no place where you get this movie key. So you place a restraint that you can only create the movie key for the fact sales if you already have this sort of data in the dimensional table. All right. So that's all it does. And you follow the same pattern. You create the tables, you name the table, then you go one by all the columns, making sure you follow the date times. As you can see, all of these are going to be ints, except the last one, sales amount, that you want to be numeric because you're going to use decimal points. And we're going to place the references constraint here. So date key, for example, is from dim date. So I want to reference this table, dim date, and from dim date, I want to reference date key, and I've placed it here. So customer key is over here. So I want to reference DEND customer, and I have it over here, and it's going to reference customer key from DEND customer. So you do the same for all the 4 tables. And sales amount, as you can see, doesn't belong to any dimensional table, so you just write it like that. Awesome. And to check your work, you run this query. That's already written for you, just making sure that this table matches this table. All right, so now we have the table where we're going to load our data. What we have to do now is extract our data from this relational database, transform it, and load it into this start schema. Okay, so here what it does is like an example of the entire process. Here here this creates the table as we did in the previous step. This and extracts the data from the RDB, transform it by naming it, and you might want to use like some more elaborated functions, and that's why the transform part of it, and you're going to load it with insert, and that's it. That's the ETL. So, and here this query is just to make sure that you did it right, and they're dropping the table over here. All right, so we are denormalizing from the ERD into this start schema. Cool. So it starts by populating the DIM date. This one over here. It's the more complicated one because it has this distinct char and like some fancy code, but it's not that hard. So let me walk you through each of this. So the distinct, basically what it does, it returns just distinct values. So you don't have any duplicates for these date key, and you don't want any duplicates ever on your primary key. So this makes sense. Then to char, what it does is basically it takes 2 arguments. It takes a date, and that date is returned to you as a char, but transforming it into a certain format. All right. So the date that I had here was from payment date. Let me show it to you. So payment date, I have it over here, and basically it's taking this date that was fairly complicated, and I'm just taking that date and I'm transforming it into this format, which is year, month, day. All right. What these double columns mean is a cast. All right. And a cast basically means take this payment date and make sure it is a date, or transform it into a date if it's not. And so I have my payment date as a date, making sure that it's a date with this cast. And then the char is going to transform it into characters following this format. And what I got from this, I'm going to cast as an integer. So the end result is this date format as an integer, and I'm going to name it date key. So that's what this part of the code does. And then this extract code, we've already used it before. From the payment date that we have over here, we're going to extract the year, the quarter, the month, the day, the week. And here I just specify the alias that I want to use. And this case, basically, it follows a Boolean decision system. And when you extract this ISO.do, which this is a day of the week, but following a format where Monday is day 1 and Sunday is day 7. If you use the regular DOW, I think Sunday is day 0. I'm not completely sure about this, but I'm sure about how it changes the behavior between ISO.DO and DO. So it changes the behavior, basically. It's like a different numbering for the days of the week. All right, so I get the days of the week. And if the day of the week is a 6 or a 7, then it's going to say true, okay? Else it's going to say false. And this is for us to know if this is a weekend or not. Okay. All right. Now is your turn. You're going to populate the DIM customer. So it's really, really simple. You start with the insert into, then you name the table, and you need to write all the columns that you're going to populate. So you start by customer key, you write it down, customer ID, first name, last name. As you can see, I wrote them over here, commas, don't forget the parenthesis, and then you're going to write a select statement to extract these columns with the matching columns in this RDB. All right. So you need to find where's this data, where does this data reside in this database. So the customer ID is going to be your customer key, and that resides in the customer table. All right. So that's pretty simple. The customer ID, well, is in the customer table. The first name is also in this table, so no biggie. Last name is also in that table, email as well. But address is no longer in this table. It's an address table. So you know that you need to join both tables there. And then address 2 is also in this table. But city is not in this table. Oh, and I forgot district, but it's in this table as well. But city is not in this table. So you need to join the city table to get this data. And then country, you need to join the country table to get this part of the data. Then the postal code is again from address, the phone is again from address, and the active and create date is from the customer table. All right. And basically, I've selected all the columns that I wanted from the correct tables and just making sure that I join them where they share values. So for example, customer and address, they share an address ID over here, address ID and address ID, right? And you do the same for all your tables. So it's pretty straightforward. It's basically what we did before, like just making sure you're writing all the columns that you want in order to populate this table, and just making sure you join the tables, right? So now we're going to populate the movie from the film and language table, and it even tells you what tables to use, all right? So you start again with just insert into the movie and then write all the columns that you want to populate in the order that you want to do so. And then, for example, film ID, where do I get that? Where that's going to be my film ID from, that is going to be my movie key. Don't forget to use the aliases that match the columns names of the star schema. All right. And then film ID, I already had it. And title is also from the film table. Description is also from the film table. Release year also from the film table. Now name is going to come from the language table, which is right here. All right. And then, so I need to join this. Then original language is going to come from the original language, which is right, where is that table? Oh, I'm sorry, I'm from the film table, so this is a mistake. I think it was like this in the video, and that's why it might be like this. Just check it, but you can take it from the film table, originals language ID. Thing is, I don't see it. It might, because I see the original language ID, but I don't see the original language table. Okay, I'm going to continue with it, but in case you don't find it, as I didn't find it right now, this code works. So there must be an original language table over there, and I'm just joining the original language table with the film table, all right? And that's pretty much it. Just making sure that, okay, so I want the rental duration because I have it right here in the DEND movie, rental duration and length and rating and special features. where in my RDB do these columns reside? And just making sure you select the correct table, all right? And then you join it into your query. Now for theme store, you follow the same process. This is theme store, just insert into theme store, then you select, you write down all the columns that you want to populate, and then where do you find all these data in this RDB, all right? And just write down the name of the tables, the alias that you're going to use for the table, and then making sure that if it doesn't have the same alias, that you write it as, and then the table, and then the alias that you want to use. For example, right here, it was from staff, it was first name, but I wanted to be manager first name in order to match this one. So I did that. All right, and I just joined the different tables. Then you do the same for the fact sales. And here we use the to char and then the code that I already explained it to you, because we're dealing with the date key, all right? And we're dealing with the date, so I wanted to use this format. That's the one that's shown in the video. So that's why I used the to char. And then I just select the different columns that I want to use to populate my fact sales table. Right, so insert into fact sales, then I listed all the elements that I want to populate. I select and I use this to get an integer that follows this format as a date key, and then customer ID as customer key that I got it from the payment table, customer ID. Then the film ID, I got it from the inventory table, film ID. And then the store ID, I also got it from the inventory table. And finally, the amount, I got it from the payment table, and I just joined each, or from the rental table, actually. No, I joined the rental table in order to get to the payment table. No, I started in the payment table and I joined the rental to get to the inventory. Sorry about that. And that's it. You've populated your tables. All right. Now we're going to do the last piece of code. Is really, really simple. Where did it go? Right, here it is. And you don't need to do anything on this one. Basically, you just run the queries. And just to make a point clear that it's really, really easier to run queries in the star schema. It's cleaner, it's faster, so it's better suited for analytical processes. And that's why you would like to use star schema as a data warehouse and update it periodically, instead of having to use your star schema that, even though it's great for operational processes, but it's going to be a hassle for analytical processes. All right, so this ETL is something that is going to be really similar to what you're going to use for the project. So I suggest you get familiar with this. And just as a brief reminder, try to advance. As you can see, we have 1, 2, 3 lessons before the project. So dedicating 2, 3 days to each lesson is feasible. As you can see, they're not that lengthy. This you're done in 2 hours. This you're done in 2 hours as well, 2 hours as well. And the project data warehouse, I think, is doing an entire month. So you spend, I don't know, a week, maybe even stretching it to 2 weeks. Then you have 2 or 3 weeks to work on the project and submit it as many times as you need. So I'm hoping that this is helpful. Don't hesitate to contact me, to send a message in the DEND session channel and schedule your one-on-ones. And it was a pleasure talking to you guys. I'm going to share this link as well as the others, and have a great learning week. See you soon.